Hi everyone, myself Sibina, faculty at Silver Hills Public School, Calicut. In this session, we are discussing about colligative properties, that is chapter 2 solutions, class 12. Colligative properties, osmotic pressure. So before moving to osmotic pressure, let's consider what is meant by a colligative properties. Properties of solution which depend only on the number of solute particles and it is independent on the nature of solute particles. Properties of solution which depend only on the number of solute particles and it is independent on the nature of solute particles. These properties are colligative properties, and the four important colligative properties are relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. In this session, we are discussing about osmotic pressure. But before moving to osmotic pressure, we have to know the differences between osmosis and diffusion. So, how can we compare osmosis and diffusion? Is it same or different phenomenon? When we consider osmosis, it takes place only through a semi-permeable membrane. So, for the process of osmosis to occur, a semi-permeable membrane is required. Semi-permeable membrane means like parchment membrane, cellophane bag, like that. And this semi-permeable membrane allows only the passage of solvent molecules. Whereas when we consider diffusion, there is no semi-permeable membrane required, or semi-permeable membrane is not required for a diffusion process. That's the main difference between a diffusion and osmosis process. Osmosis occurs only through a semi-permeable membrane, whereas diffusion, semi-permeable membrane is not required. And second main difference between osmosis and diffusion, osmosis involves the movement of solvent molecules only. That is why it is only through a semi-permeable membrane. And this SPM, semi-permeable membrane, allows only the passage of solvent molecules. And one more, the main important point related to osmosis is that it is limited to solutions only. Osmosis is limited to solutions only. But when we consider diffusion, it is common in gases as well as in solutions also. For example, we know that gases, it diffuses from its higher concentration to lower concentration. And there is no boundary for a diffusion process. Therefore, diffusion cannot be reversed or it cannot be stopped. We can't stop diffusion process. We can't reverse a diffusion process. It's like a natural phenomenon. It flows from its higher concentration to the lower concentration. Whereas when we consider osmosis, it involves the movement of solvent molecules from a region of higher concentration of solvent molecules into the region of lower concentration of solvent molecules. Or we can say that it is the movement of solvent from a region of lower concentration of solution into a region of higher concentration of solution. Repeating, osmosis, it is the movement of solvent molecules from a region of lower concentration of solution into a region of higher concentration of solution. And in diffusion, it is the movement of particles. It may be solute particle or it may be solvent particles move from a region of higher concentration into a region of lower concentration. That means in diffusion, both the solute and the solvent molecules are involved. Whereas in osmosis, only the solvent molecules are involved. So, the detailed definition of osmosis is that the phenomenon of flow of solvent through a semi-permeable membrane from pure solvent to the solution. So, 3 points. It should occur through a semi-permeable membrane. Second point, from pure solvent to the solution. And third point, it is the movement of solvent molecules. This phenomenon is called osmosis. Now, osmosis, when we consider osmosis, it can be stopped or reversed by applying an additional pressure on the higher concentration side. Usually we are applying the pressure on the solution side. So by applying a pressure, we can stop or reverse osmosis process. Whereas diffusion, we can't stop or we can't reverse a diffusion process. Now we are moving to the colligative property, the fourth colligative property, that is osmotic pressure. So what is meant by osmotic pressure? It's related to osmosis, that is clear from the term itself. The excess pressure which must be applied to the solution side in order to prevent the passage of solvent through the semi-permeable membrane. It is the excess pressure that must be applied to the solution side in order to prevent the passage of solvent molecules through it, that means through the semi-permeable membrane, is called osmotic pressure. In order to determine osmotic pressure, a scientist called Van Hoek, he observed that for dilute solution, osmotic pressure pi, it is given as pi equal to CRT. Pi stands for osmotic pressure. C, it is a concentration of solution and that is expressed in molarity. For all the other colligative properties like elevation in boiling point, depression in freezing point or relative lowering in vapor pressure, the concentration of solution be expressed in terms of molarity small m. But in the case of osmotic pressure, the concentration will be expressing in terms of molarity capital M. R, universal gas constant, T, temperature. So osmotic pressure pi equal to CRT. C stands for molarity of the solution, R, universal gas constant, T, temperature of the solution. R is a universal gas constant, T temperature and C molar concentration. Then how can we determine the molar mass of solute by using osmotic pressure? For that, we can apply in the Van Hoek equation pi equal to CRT, where C stands for molarity. And we know that molarity of a solution is given by the formula number of moles of solute by volume of solution in liter. Number of moles per liter of solution is called molarity of the solution. So molarity equal to N by V. N, number of moles of solute, V, volume of solution in liter. So the osmotic pressure pi equal to N by V into RT. Then this Van Hoek equation, again we can modify it as pi V equal to nRT, where pi stands for osmotic pressure, V, volume of solution in liter, N, number of moles of solute, R, universal gas constant, and T, temperature of the solution, that should be in terms of Kelvin. Then just rearrange this equation, pi equal to WB by MB into RT by V. MB equal to WB into RT by V into pi, where MB, it's a molar mass of solute, WB, weight of solute, R, universal gas constant, T, temperature of solution in Kelvin, V, volume of solution, pi, osmotic pressure. So if we know all these variables, we can calculate MB, that is molar mass of solute. Now, in order to get the accurate value of molar masses of solute by using osmotic pressure, there are three conditions are there, and the first condition is the solute must be non-volatile. In the second condition, the solution must be dilute. Usually for dilute solutions only, we can apply osmotic pressure. And the third condition is that, this is a very important condition, that means the solute must not undergo dissociation or association in the solution. What is meant by dissociation? For example, sodium chloride. Sodium chloride solution, we know that in sodium chloride, it will be in the form of Na plus and Cl minus. So it is get dissociated into positively charged ions and negatively charged ions. Similarly, if we consider an acid solution, it will be in the form of dimer. So what is happening during dissociation or association? If there is a dissociation, number of particles in the solution is increasing. It is get converted to positive ions and negative ions. So the number of ions in the solution is increasing. And if it is in association, the molecules get associated to form dimers. So as a result, number of particles in the solution is decreasing. So in both cases, whether it is association or dissociation, it affects the number of particles in the solution. And we know that colligative properties means it depends only on the number of particles in the solution. And it is independent on the nature of particles in the solution. So if there is any dissociation or association in the solution, it will affect the osmotic pressure. So the three important conditions in order to get the accurate value of molar mass is that the first one, the solute must be non-volatile. Second one, the solution must be dilute. And the third condition is very important, the solute must not undergo any association or dissociation. Now, based on the value of osmotic pressure, there are three different types of solutions are there. The first one, isotonic solution. Isotonic solution means the solutions which have the same osmotic pressure. Let's consider two solutions, A and B. If the osmotic pressure of both A and B are equal, then the two solutions are called isotonic solutions. Second one, hypertonic solution. From the name itself, it is hypertonic solution. Let's consider two solutions, A and B. If the osmotic pressure of A is greater than B, then A is called hypertonic solution and B is called hypotonic solution. Why? Osmotic pressure of B, it is less than as compared to B. So B, hypotonic solution, because its osmotic pressure is less than compared to the solution A. So there are three types of solutions based on osmotic pressure. Isotonic, same osmotic pressure. Hypertonic, if it has more osmotic pressure compared to a standard solution. Hypotonic, if the osmotic pressure of solution is less than compared to any other solution. There is one more phenomenon is there related to osmosis, and that is reverse osmosis. From the name itself, the osmosis is reversed. How can we occur a reverse osmosis? So, the process of osmosis can be reversed if we are applying a pressure that should be greater than the osmotic pressure, and that should be applied on the solution side. Two conditions, the pressure should be greater than osmotic pressure and that should be applied on the solution side. Then the osmosis process that can be reversed. As a result, what will happen? The solvent molecules move from the solution side to the pure solvent side through the semi-permeable membrane. So, if we are applying a pressure greater than the osmotic pressure on the solution side, the solvent molecules move from the solution to the solvent through the semi-permeable membrane. Then that phenomenon is called reverse osmosis. Now let's consider a problem related to osmotic pressure. 200 centimeter cube of an aqueous solution of a protein contains 1.26 gram of protein. The osmotic pressure of solution at 300 Kelvin is found to be 2.57 into 10 raised to minus 3 bar. So let's consider what are the values given. 200 centimeter cube of an aqueous solution. So volume of solution equal to 200 centimeter cube. Contains 1.26 gram of protein. So weight of solute, that is protein, equal to 1.26 gram. At that time, the osmotic pressure of solution is found to be 2.57 into 10 raised to minus 3 bar. Pi equal to 2.57 into 10 raised to minus 3 bar. And the temperature of solution is also given at 300 Kelvin. So MB equal to WB into RT by V into pi, where MB molar mass of solute, WB, weight of solute, R, universal gas constant, T, temperature, V, volume of solution, by osmotic pressure. Let's substitute all these values in the equation MB. WB 1.26, R 0.083, liter, bar, mole inverse, Kelvin inverse, temperature 300 Kelvin, volume 0.2 liter, pi osmotic pressure 2.57 into 10 raised to minus 3 bar. After calculation, you will get MB equal to 61039 gram per mole. So, molecular mass of protein in this condition is equal to 61039 gram per mole. So, we discussed what is osmotic pressure, what is reverse osmosis, and also we discussed Van Hoff equation. Hope this concept clear for you. Thank you.